Hi everyone, in this video we're going to work on applying transformations to the graph of tangent. I should point out here that not all of the vocab for sine and cosine makes sense for tangent, so we won't talk about amplitude on tangent because it goes up forever and down forever. We can talk about phase shift. We still shift horizontally and that moves our asymptotes. I don't know if I think equilibrium quite applies, but you can kind of think that concept where your vertical shift is going to move what's called the inflection point on tangent. So it goes like this and then like this. And notice that here we have this kind of downward bend and then sort of an upward bend. And this point right in the middle is called the inflection point. So vertical shift will move where that bend change happens. What else do we have? We do still get to talk about period. So period and phase shift are good stuff. Okay, what else do I want to say here? So this is what I'm picturing. This is one full period of tangent, and we should be trying to commit to memory or to use our unit circle to help us figure out that those asymptotes are at negative pi over 2 and pi over 2. So it'll be really important to pay attention to where those go. We don't need to get super picky with the all the details of the graph of tangent. I want you to have the idea of what it looks like, but we aren't going to worry a ton about what's going on with the y values, maybe just a little bit, but I'm not going to be picky about that when I'm looking at these. So we'll worry about period, we'll worry if we've shifted our asymptotes and intercepts left or right, we'll worry about flipping upside down, that definitely changes the shape. Those are the big ones we want to watch for. Okay, so let's see. Here I do have the flip. That's out in front of the function, so that's going to flip us over the x-axis. So we'll be getting this upside down tangent graph. And then the x divided by 4, the dividing by 4 is horizontal stretch. So we will be changing the period. Okay, so let's see if we can walk through some of these things. So the period is going to be pi divided by 1/4, which is the same as pi multiplied by 4, or 4 pi. Okay, so normally tangent has a period of pi. Negative pi over 2 to pi over 2 for this section gives me one full period. Now it's going to be 4 pi, so I've stretched it horizontally quite a bit. So I have this upside down looking tangent graph, and I've stretched it out a lot. So let's go ahead and put some axes in the mix here. I can't tell where the middle is. We'll say it's here. That looks pretty good. Maybe I'm crooked. And here. Okay, so 4 pi. Let's see. So I'm going to label this. I'm just going to go pi and 2 pi and 3 pi and negative pi and negative 2 pi and negative 3 pi and negative 4 pi. Okay. So we've got just about 2 full periods that would fit in here. So when we do this horizontal stretch, let's see, it's fairly easy to figure out what happens to our asymptotes. So if I have an asymptote at x equals negative pi over 2, when I do horizontal stretch, that's going to get multiplied by 4. So 4 times negative pi over 2 is going to be a negative 2 pi. So at negative 2 pi, I'll have a vertical asymptote. And really, we could kind of use the trick we did for sine. Once we get that as a starting place, we know the graph's upside down, and we could do something similar where we say, well, we know the full period is, I just said it, 4 pi. So if I go 4 pi over from an asymptote, I should be at the next asymptote. Right in the middle of the asymptotes, you should always hit your intercept. Unless you shift it up or down, it won't be an intercept anymore, but generally that's where that would end up. So that's one option. If you don't like that option, it is also pretty easy to say, okay, we can do the same thing, apply our transformation to x equals pi over 2. I don't know if I said it, so I should say it now. The flip does happen to the vertical asymptotes, but if you take a vertical line and flip it upside down, it looks the same. So I'm not really worrying about the flip, just the stretch. So that's going to land this thing out at positive 2 pi. And then, like I said, you can just take for granted that this inflection point always happens exactly in the middle of the asymptotes. Or you can say, I have the point 0, 0. If I flip upside down, it doesn't move. And if I do horizontal stretch, it doesn't move. So it's still sitting right at 0, 0. So there's kind of general shape, and then, or I'm sorry, general structure, and then the shape will be that upside down looking tangent. I really am fine with not being too picky about your vertical scales, but if you want to be just a little picky to try and get in the ballpark, really nice points to follow are pi over 4, 1 and negative pi over 4, negative 1. So we can say, all right, I had pi over 4, 1. I flip, it lands at pi over 4. Let's see, pi over 4 is way in here. Pi over 4, negative 1. We'll just say this is 1, negative 1. And then we're doing, okay, so we're at pi over 4, 1. We're doing horizontal stretch by 4. So that's going to put us way out at pi negative 1. And then similarly with the negative pi over 4, negative 1. So negative pi over 4, negative 1. We flip, it lands at negative pi over 4, 1. And then we stretch, and it lands at pi 1. So if you want a couple more points just to get slightly more accurate, those are fairly nice points to follow. But the big thing I'm going to be looking for is if there's a flip, did you catch it? Where the vertical asymptotes, where is this inflection point or your intercepts if you haven't vertically shifted. That's kind of what I'm going for. And then this will repeat again. So you should have asymptotes every 4 pi, which means the next one will be over at negative 6 pi. There would be another one. So I think I lied. I didn't quite give myself room for very nice 2 periods. And then there'll be the intercept, the inflection point happens every 4 pi. So if there's one at 0, there'll be one at negative 4 pi. So we're just going to get a duplicate of this on this side. And same thing on the other side. That goes on forever. Okay, so there's one, and again, really emphasis here. I want you to know what tangent looks like, but I don't want to get too crazy and particular about the details. I just want to be able to figure out this general shape, figure out where an asymptote is if needed. Let's go ahead on this one, since it's a little more interesting, and talk about domain. The range is all real numbers, but the domain has that new notation going on, so that's probably good for us to practice. So here, if I want to talk about domain, I would want to say that, oh, it's x's in this problem. X does not equal, and I want to say it doesn't equal a lot of things. So I want to say it doesn't equal negative 6 pi or negative 2 pi or positive 2 pi or positive 6 pi or positive 10 pi. Remember, these are 4 pi apart. So I'm just going to pick one as the starting point to kind of show this pattern. I'm going to say x doesn't equal 2 pi. Doesn't matter which one you pick, so feel free to pick negative 2 pi or negative 6 pi or whatever you want. And then I want to say not that anything an integer multiple of pi away is bad, but anything that's an integer multiple of 4 pi away. So I'm going to say 4 pi k, or whatever you want to put that in. So notice, you can check yourself. If k is 0, then I get just 2 pi, which is this one. If k is 1, I get 2 pi plus 4 pi. That's the 6 pi that I mentioned. If k is negative 1, I get 2 pi minus 4 pi, the negative 2 pi. If k is negative 2, I get 2 pi minus 8 pi. That's my negative 6. So I am getting what I'm hoping for. You do need to specify that k is an integer. So you can either use my lazy person math notation, k is an element of the integers, z means integers, or you can write out the words k is an integer. But it is really important to me that you mention that. If you don't force k to be an integer, then you could say, oh, well, k equals 1/2 gives me 2 pi plus 2 pi plus 2 pi, which is 4 pi, and I'm not supposed to have an asymptote there. Okay, let's go ahead and run through one more, not too messy. I did do a vertical shift. I don't want to do big emphasis on this, but I do want to be sort of aware of what's going to happen here. So now I have my typical tangent graph, and this will be a pi over 2 and negative pi over 2, and I want to do vertical stretch by a factor of 2, and I want to shift down 1. So, thinking about my asymptote, so let's start with x equals negative pi over 2. If I do vertical stretch on a vertical line, not really very impressive. It's going to stay the same. If I shift down 1, still not very impressive, still going to stay the same. So let's go ahead and draw in our vertical asymptote at negative pi over 2. So let's say this is a negative pi over 2. And similarly for the positive pi over 2, if we start at positive pi over 2, vertical stretch doesn't move it, shifting down doesn't move it, so it's still at positive pi over 2. Okay, so we have asymptotes where we usually had them. And notice we don't have any horizontal structure compression, so the period of this is going to be just like your standard tangent graph. It's going to be a period of pi. So from here, if we go another pi, so pi over 2, and then a pi over 2 would get you to pi, and then another one would get you to 3 pi over 2. There'll be your next asymptote, and the same on the other side. There's a negative pi, a negative 3 pi over 2. Okay, so those are our asymptotes. The intercept, 0, 0, the vertical stretch won't affect that, but shifting down 1 will. So it does land at 0, negative 1. So our inflection points have shifted down, and there should be one with that same y-coordinate in the middle. So we would have had x-intercepts right in the middle of each set of asymptotes, but we moved it down 1. And that will be where the bend changes. So we will expect to see that kind of curve thing happening, the little S-curve thing happening right in the middle. You can get a pretty good general shape here. Again, if you're feeling a little bit weird about the details, you can always snag a pi over 4, 1 and say, all right, so pi over 4, 1, if I stretch, that moves to pi over 4, 2. And then if I shift down 1, it actually lands right back where it started. And if you want to do that with pi over 4, negative pi over 4, negative 1, the stretch will land it at negative pi over 4, negative 2, and then shifting down 1 will make it negative pi over 4, negative 3. So it is stretched out a little taller. And the bend happens below the axis. The change in bend happens below the axis instead of above, but we still have that pretty typical looking tangent shape. So there's 2 full periods. We can add one here as well if we want to. Okay. So there's one with a vertical shift and a vertical stretch. So not our most important transformations in my eyes. We're just kind of trying to have this general shape. So I'm more worried about changing period and shifting horizontally because that changes our domain. We can say here what our domain is. Here we would want to say x does not equal, let's start with negative pi over 2 to be different. Or anything that's pi units away. So our period is pi. We're going to have a plus k pi where k is an integer. All right, thanks for watching.